Statistics and probability.
Good morning. Welcome to our subject, Statistics and Probability. Today, we will talk about two sample case, comparing the mean or proportion of two groups. Watch and listen to this video lesson. So what is a two sample case test? Do you have any idea? Here is the definition and formula of two sample case comparing the means. The independent z-test or t-test, also called as two-sample z-test or t-test, is an inferential statistical test that determines whether there is a statistical significant difference between the means in two unrelated groups. Formula. Let's start with the z-test. Z used for n or the sample size is greater than 30. If z is equal to the sample mean of the first group minus the sample mean of the second group all over the square root of the square of SP over the sample size of first sample or first group plus square root of SP divided by the sample size of the second group. For n which is less than 30 or sample size less than 30 and variances are assumed to be equal, we use t-test. Here, our t is equal to the sample mean of the first group minus the sample mean of the second group divided by the square root of the square of SP divided by the sample size of the first group plus the square of SP divided by the sample size of the second group, wherein our degrees of freedom is equal to n sub 1 or the sample size of the first group plus the sample size of the second group minus 2, where our square of SP is equal to the product of the quantity of sample size of the first group minus 1 times to the square of the standard deviation of group 1 plus the product of the sample size of group 2 minus 1 times the square of the standard deviation of second group all over the sum of the sample size of group 1 and group 2 minus 2. Let's have some examples of conducting hypothesis testing involving two sample case z-test or t-test. Two methods, A and B, were used to teach a high school algebra course. At the end of the semester, random samples of the final averages for the two methods were obtained. The sample information is given below. For method A, our sample size is 55, the sample mean is 87, and the sample standard deviation is 6. For method B, our sample size is 40, the sample mean is 82, and the sample standard deviation is 5. Using a 0.01 level of significance, test whether method A is more effective than method B. Step 1. Our null hypothesis. There is no significant difference in the result using method A and method B. In symbols, the sample mean of A is equal to the sample mean of B. Alternative hypothesis, the result is better using method A than method B. So meaning the sample mean of A should be greater than the sample mean of B. And we use greater than, so it is directional. Step 2, our level of significance, based on the statement, it is 0.01. Step 3, our test statistic. The appropriate test statistic for this is the z-test for two sample case. Z-test because our sample size is greater than 30, 55, and 40. So meaning it's greater than 30. So z-test for two sample case. So step 4, since our alternative hypothesis is directional and our level of significance is 0.01, so our critical value is 2.326. This means that if the computed z is greater than 2.326, then the null hypothesis will be rejected. and accept the alternative hypothesis. If not, then accept the null hypothesis. Step 5. The formula in computing for Z. Given the sample mean of A is 87, the sample mean of B is 82, the standard deviation of group A is 6, and the sample standard deviation of group B is 5, and the sample size of A is 55, and the sample size of B is 40. We solve first for the S squared P, S square of SP. So, using the formula, so our n sub 1 or our first sample size is 55 minus 1 times the square of the standard deviation of the group 1, which is 6 squared, plus 40 minus 1 times 5 squared all over 55 plus 40 minus 2. Simplifying, 55 minus 1 is 54, square of 6 is 36, 40 minus 1 is 39, and square of 5 is 25. Divided by, so 55 plus 40 is 95 minus 2, 93. So now we have 54 times 36 is 1,944. And 39 times 25 is 975. So that's why our numerator is 1,944 plus 975 all over 93. So we have here 2,919 all over 93. Using our calculator, it's 31.3871. Then, using the Z, so our Z is equal to 87 minus 82 all over the square root of 31.3871 over 55 plus 31.3871 over 40. So 87 minus 82 is 5. So we have here 0.5707. That's 31.37 divided by 55. And the other one is 0.7847 from 31.3871 divided by 40. So we have here 5 divided by the square root of 1.3554. And that is 5 over 1.1642 or 4.29. Step 6, our decision making. Since the computed value of Z is 4.29, which is greater than 2.326, the null hypothesis is rejected. Therefore, the result is better using method A than method B. Furthermore, it is recommended to use method A. Let's have the second example. To determine which type of fertilizer X or Y is more effective in increasing the average yield of certain potatoes planted on the same ground, a farmer recorded the yields of potatoes as shown below. Is there a significant difference between the mean yield of potatoes using fertilizer X or Y? Use 0.05 level of significance and assume the population variances to be equal. So our fertilizer X has a sample size of 9, sample mean of 15.11, and a sample standard deviation of 4.54. For fertilizer Y, sample size of 9, sample mean of 12.89, and a sample standard deviation of 2.62. Step 1. So our null hypothesis, there is no significant difference on the mean yield of potatoes using fertilizer X or Y. In symbol, meaning the sample mean of X should be equal to the sample mean of Y. Our alternative hypothesis, there's a significant difference on the mean yield of potatoes using fertilizer X or Y. So meaning, the sample X is not equal to the sample Y. It is non-directional because of the symbol not equal. Step 2. So, our level of significance is 0.05. Step 3. So, since our sample size is less than 30, so we use t-test for 2 sample case. Step 4. So we use the t-table in order for us to determine our critical value. So since it is non-directional, so we use the two-sided P. So two-sided P, you look for 0.05. That's our level of significance in two-sided P. So that's the 0.05 on two-sided P of our level of significance, which is 0.05. And for our degrees of freedom, 9 plus 9 minus 2 is 16. So we look for 16. And then the intersection of the two is our critical value. Since our alternative hypothesis is non-directional and our alpha is 0.05, the critical value based in the table is positive negative 2.120. This means that if the computed t is greater than 2.120 or less than negative 2.120, then the null hypothesis will be rejected and accept the alternative hypothesis. If not, then accept the null hypothesis. So now let's have the computation of our t, step 5. So we use this formula. So given that our sample mean of x is 15.11, sample mean of y is 12.89, and the sample standard deviation of x is 4.54, and the sample standard deviation of y is 2.62, and the sample size of x is 9, and sample size of y is 9. So we'll solve first the square of SP, which is this one. So we use the formula. We substitute the given to the formula. That's why we have 9 minus 1 and the square of the standard deviation. Then 9 minus 1, the square of the second standard deviation. And then 9 plus 9 minus 2. So we have here 8. That's from 9 minus 1. And the square of 4.54 is 20.61. And the square of 2.62 is 6.86. So 9 plus 9 minus 2 is 16. So we have 164.88 plus 54.88 over 16. And to simplify that, we have 219.76 over 16, or we have 13.74. Then substitute our given to the formula for t, which is t equal to 15.11 minus 12.89 over the square root of 13.74 over 9 plus 13.74 over 9. So our t is equal to 2.22 divided by the square root of 1.5267 plus 1.5267. Then we have 2.22 over the square root of 3.0534, or 2.22 over 1.7474, or a simplification, we have our t, which is 1.27. So for our step 6, for our decision making, since the computed value of t is 1.27, which is less than 2.120, the null hypothesis is accepted. Therefore, there is no significant difference on the mean yield of potatoes using fertilizer X or Y. Furthermore, any brand of fertilizer can yield a certain potato of the same amount. It is your turn to answer. Conduct hypothesis testing to this problem. A men's group claims that they are smarter compared to women. They cite the result of a study of 2016 college admission test. The information is given below. A group of men, 36. So there are 36 men with a sample mean of 108 and a sample standard deviation of 10. And there are 38 women here. So sample mean of 105 and a sample standard deviation of 11. So using 0.05 level of significance test whether men are smarter than women. Pause this video and answer for 10 minutes.
A few moments later.
Let's reveal the answer. Step 1. Our null hypothesis. There's no significant difference in the intelligence of men and women. This is the symbol. Our alternative hypothesis, men are smarter than women, and we have here the symbol and it is directional. Step 2, our level of significance is 0.05, and step 3, we use the z-test for two sample case. Step 4, the critical value is 1.645. This means that if the computed z is greater than 1.645, then the null hypothesis will be rejected and accept the alternative hypothesis. If not, then accept the null hypothesis. Step 5, this is our formula with our given. The sample mean for men is 108, the sample mean for women is 105. Standard deviation for men is 10. The standard deviation for women is 11. The sample size of group of men is 36, and the sample size of group of women is 38. So we solve first the square of SP. So we have here the quantity of 36 minus 1 times the square of 10 plus the quantity of 38 minus 1 times square of 11 all over 36 plus 38 minus 2. And then we have 35 from 36 minus 1 and 100 from the square of 10. So that's why we have there 35 times 100 plus 37 times 121. Our 37 there comes from 38 minus 1 and 121 is the square of 11. All over 72. So our 72 comes from 38 plus 36 minus 2. And then 35 times 100 is 3,500. And 37 times 121 is 4,477. That's why we have there 3,500 plus 4,477 all over 72. And then we have 7,977 over 72 or 110.7917. Substitute the values to our z. So our z is equal to 108 minus 105 all over the square root of 110.7917 over 36 plus 110.7917 over 38. Then we come up with 3 over the square root of 3.0775 plus 2.9156. Then we have 3 over the square root of 5.9931, and the square root of 5.9931 is 2.4481. That's why we have 3 over 2.4481, and it is equal to 1.23. Step 6. Since the computed value z is 1.23, which is less than 1.645, the null hypothesis is accepted. Therefore, there's no significant difference in the intelligence of men and women. Furthermore, their claim is not right. Let's now have comparing the proportions. The purpose of z-test for independent proportions is to compare two independent proportions. And this is the formula for the z for independent proportions. P sub 1 is the proportion for first group, P sub 2 is the proportion for second group, and P is the proportion of two groups. Let's have an example. A study was conducted to determine whether method X will enable the students to be successful in statistics course. Success in the course would mean that a student receive a grade of at least 80. The data are shown below. So under gun method X, there are 100 sample and number of successes 70. Did not undergo method X, we have 40 sample and number of successes is 16. Test at 0.05 level of significance on whether method X helped the students to be more successful. Step 1. Null hypothesis. There's no significant difference in the proportion of students undergone method X and did not undergo method X become successful in statistics course. So this is our symbol. The P sub 1 is just equal to P sub 2. In our alternative hypothesis, there's a significant difference on the proportion of students undergone method X and did not undergo method X become successful in statistics course, meaning the P sub 1 is not equal to P sub 2 and it is non-directional. So our level of significance is 0.05 and our step 3, our propriety test statistic is z-test for two sample case or z-test for independent proportions. Step 4. The critical value is positive negative 1.96. This means that if the computed z is greater than 1.96 or less than negative 1.96, then the null hypothesis will be rejected and accept the alternative hypothesis. If not, then accept the null hypothesis. Step 5. This is the formula for z for independent proportion. So our given, so first our proportion of group 1 is 0.7. So that comes from 70 divided by 100. And our P sub 2 is 0.4. It comes from 16 divided by 14. And our P for both groups, so 70 plus 16 over 100 plus 40 is equal to 0.61. And our Q is 1 minus 0.61, 0.39. The sample size of the first group is 100 and the sample size of second group is 40. So, using the formula, Z is equal to 0.7 minus 0.4 divided by the square root of 0.61 multiplied to 0.39 and multiplied to the quantity of 1 over 100 plus 1 over 40. So, we have here 0.3 over the square root of 0.2379. That's the product of 0.61 and 0.39. 0.01 plus 0.025, that's our fraction from 1 over 100 becomes 0.01 and 1 over 40 that becomes 0.025. And then we come up with 0.3 over the square root of 0.008327. And then it becomes 0.3 divided by 0.09125 or equals Z equals 3.29. Since the computed value of Z is 3.29, which is greater than 1.96, the null hypothesis is rejected. Therefore, there's a significant difference in the proportion of students undergone method X being successful compared to the proportion of students that undergo method X. Furthermore, method X is effective. It's your turn to answer. Conduct a hypothesis testing to this problem. A sample of 500 items produced by machine A show that 39 are defective. A sample of 400 items produced by machine B show that 31 are defective. At 0.01 level of significance, which machine would you prefer to purchase? Pause this video and answer for 10 minutes.
A few moments later.
Let's have the answers. Step 1. Null hypothesis. There's no significant difference on the proportion of production of machine A and machine B. This is the symbol. Alternative hypothesis, there is a significant difference on the proportion of production of machine A and machine B. And this is the symbol and it is non-directional. Step 2. Our level of significance is 0.01. And step 3, our test statistic is z-test for two sample case or z-test for independent proportion. Step 4. The critical value is positive and negative 2.576. This means that if the computed z is greater than 2.576 or less than 2.576, negative 2.576, then the null hypothesis will be rejected and accept the alternative hypothesis. If not, then accept the null hypothesis. Step 5. Our formula for z of independent proportion, given that our p sub 1 is 0.078, that is 39 divided by 500. Our p sub 2 is 0.0775, that is 31 divided by 400. And our P is 0.778. And then our Q is 0.9222. And our sample size of the first group is 500. And the sample size of the second group is 400. Using the formula, our Z is equal to 0.0780 minus 0.775 divided by the square root of the product of 0.778 and 0.99 and 0.9222, then multiply to the sum of 1 over 500 plus 1 over 400. So we have here z equals 0.0005 all over the square root of 0.0717 times the sum of 0.02 and 0.0025. Then we come up here with 0.0005 over the square root of 0.000322265. And then it becomes 0.005 over 0.01796 or 0.028. Since the computed value of z is 0.028, which is lesser than 2.576, the null hypothesis is accepted. Therefore, there is no significant difference in the proportion of production between two machines. Furthermore, you can buy any of the two machines because they produce more likely the same amount of products. If you have some suggestions, comments, and queries regarding our topic, just give your thoughts under comment section or directly ask me through Messenger. Thank you and see you next topic.